Let's give it another minute or two, everyone, as we let everyone join in here. Thank you, everyone, for joining the 51 and Mosaic AI webinar. We're going to be doing a nice dive here on all things 51 and how you can use Mosaic AI's or Databricks Vector Search in order to empower your workflows. Jimmy is being so helpful to drop a bunch of different links in the chat if you want to kind of follow along here. To give everyone an idea of kind of what I have planned today, I will do a very quick overview of 51 to make sure everyone is kind of on the same page here of what 51 is providing to this workflow. And then we'll dive in deep about how you can use your Databricks instances, specifically with the Databricks Vector Search from Mosaic AI, to get the most out of your autonomous vehicle workflows, or really any industry that you're working with in this case. So we're going to start with a quick overview, and then we're going to get real hands-on, look at some code, see how you can power up through these integrations. Throughout it, I'll be sure to drop a bunch of different code samples to make sure that if you want to run anything that I am showing you on the screen, you'll be able to at home, as well as a couple other fun demos along as well of some things that both our customers and open source users are doing today, both in 51 open source and in 51 teams with Databricks. To help me out a little bit here, it would be super cool if everyone could just drop in the chat where you're phoning in from, and if you have heard of 51 before, could help everyone here. So for instance, I am phoning in here from New York City. I have heard of 51, so I'm just going to put a 51 in the chat. Put a 50 if you have not used 51 before. Will kind of help me make sure I'm not doing too much intro or too technical for everyone. I want to make sure that everyone is on the same page here. So thank you everyone who's dropping that into the chat right now. Okay, so nice mix of some beginners, a nice mix of some people who have heard of 51 before. So great, great, great. We are getting a couple minutes past the top of the hour, so we are going to dive in here. Welcome again, if you are just joining to this webinar. This is our first of many that we are going to be doing over the next couple months, where about every other week we will be doing a customer or a partnership spotlight with one of our partners, this case Databricks and Mosaic AI. So keep your eye out for future ones to come over the couple of weeks. You can always find those as Jimmy has dropped into our chat here on the Voxel51 events page. Be sure to see all the events that are coming up, including our partnership spotlights. So jumping into it here, I have some classical slides here that I'm excited. I haven't shown these one in a while. We're starting with the villain of bad data, and the villain of the villain of ML is always going to be bad data, whether it's model bias issues, lethal physical danger, or even just a reduction in model performance. Now in 2025. Bad data is no longer just a laughing matter. It's not a matter of if you're going to get your correct accuracy points or if you're going to do well enough in your lab. These models are being deployed to real places with real people's lives on the stake, and everything needs to be as tight-knit as possible to make sure that we're delivering the best possible model that is ultimately going to be put in our users and customers' hands. However, finding the best data set can be very difficult, right? Especially in the world of autonomous vehicles. You're dealing with petabytes of data, right? I've talked to a lot of autonomous vehicle companies where it seems like data is going to expand exponentially over the couple years. One company cited that they got a petabyte of data last year, and they're expecting 4 petabytes of data this year. So it's just a mass amount of data. How do you make sense of anything that's actually happening inside of this data lake or data source? And we're going to be showing you that with 51, we can make this task much easier for you. By leveraging tools like Databricks and Vector Search, you'll be able to find exactly what you're looking for, no matter what type of sample you're working with. So a quick note about Voxel51 and the instructor myself. Voxel51 is the company behind the open source tool 51. We are the lean maintainers of the open source. We also provide the enterprise tool called 51 Enterprise, which allows you to scale up your deployments, share across team members, and have some really, really cool features that allow you to explore your data lake using Databricks and 51 in many neat ways that we'll also take a peek at today. If you don't know what exactly a voxel is to a video what a pixel is to an image. It's that volume element in the space-time of a video. And what's with the 51? This was a fun point of contention over the last week where we just came back from CVPR. Our co-founders have now split on the answer here. I know the true answer is that 51 comes from Area 51 because all the future tech and super cool things that are going to be developed first start in Area 51. So your super cool model of the future should also start in 51. But as one co-founder likes to joke now, Jason Corso, he had 50 bad ideas and then he had 51. And a little bit about myself. My name's Dan. I'll be leading us through this webinar. I'm a machine learning engineer and developer evangelist at Voxel51. I help on our DevRel team doing a bunch of community events as well as partnership engagements. We're always making new trips around the world to bring this kind of content to you, whether it's in Germany, in Europe, in the United States, or even now in Asia, will be in future. We're always eager to put on these new events and bring new knowledge to you guys. So if you guys are interested in speaking, participating, or even helping co-host one of these events, feel free to reach out to me and Jimmy at the conclusion of this event and to learn how you can get involved. So we're going to do a quick introduction to 51, and then we're going to jump into some cool code and get involved. So what is 51? If you have never heard of 51 before, this goes to all our 50 people in the chat. 51 in a nutshell is a dataset curation tool. You can almost think about it like a dataset debugger. 51 allows you to visualize, clean, and curate your data sets, but it also lets you help find those hidden things inside it, those outliers, the clusters that don't quite make sense, those mistaken labels, as well as after you train your model on this data set, it'll help you evaluate your models, making sure you're getting to the absolute pinpoints of where the model is doing well and where your model is failing. That way you can make these changes over time to get to the best data set possible, which is ultimately going to train the best model. The most important part about 51 is that it's flexible, customizable, and connected. 51 was built for builders. We don't believe in one-button solutions. If you have a piece of code that you're really passionate about, a visualizer, if you want to just go in and make it a little bit more of your own, 51 is completely open to doing this. It's very pluggable, it's very easy to work with, and it being open source, it's very transparent about what is happening under the hood. It is the open source tool for building high-quality data sets and computer vision models, and it is trusted by companies and users across the globe. So some core capabilities about how we can leverage 51, and this will come very important in our workshop today as we get to the vector search portion, is that 51 helps you find, filter, match, sort, or select exactly what you're looking for here. So by any number of the metadata that you've stored on your 51 data set, you can begin to filter, sort, query, and kind of get down to those segments you're looking for, especially whenever it comes to things like natural search and language search using vector search like we'll see later. You can also do things like remove duplicates, remove spurious labels, find those poor quality data samples. That way we're removing them on our training set before we ever get to training. Of course, too, we can add any amount of metadata onto our 51 data set, whether it's things like velocity, GPS coordinates, or just if you like this picture or not. Everything is taggable, and we can store pretty much any Python object on any 51 sample. You can also go in, correct these mistakes before we get to our training. So if you find these annotation mistakes, such as mislabeled cats or something else, we can always clean them up before our next training run to make sure that we're only training on that high quality data as well. All in all, too, of course, you're going to find interesting things with 51. Hopefully that is the entire point as you find these most important parts of your data set that you either want to train on, come back to, outliers, or just an interesting subset that you want to evaluate further on. You can save anything that you find in 51 under saved views and then come back to it with only a couple clips in 51. It should be mentioned as well, as we see here, this is our 51 app. 51 is broken up into three main portions, all of three, which we'll be exploring today. The first one is, of course, what you're seeing right here is the 51 app. This is the front end door into your computer vision data set, which is completely able to connect, click around, and search, sort through. Everything you're seeing here, though, is backed by a Python SDK, something that you can work with in code to add your data sets in, add your own model predictions, evaluate, and more. So everything you could be done in the app can also be done purely in Python code. And then lastly, as we'll jump into here, is our 51 brain. Help you visualize things such as embeddings, do similarity search, or connect to your vector search engines, as we'll see today as well. And everything in 51 is interactive. It's very clickable. You can do things such as GPS coordinates, embedding circles, and much, much more that allow you to interact with your data able to find exactly what you're looking for. If you haven't caught on yet, FiftyOne is a premier tool to help you understand exactly what is happening in your data set. It's not about fixing everything with a click of a button, but can I get from a million samples that are, too much for you to look at and really hone in on the 100, maybe 1,000 samples that I think you, the expert of your data, really need to pay attention to. Everything can be backed up by evaluation too, whether it's one number metrics, plots, confusion matrices, or analysis. Everything on your evaluation is stored onto your data set with FiftyOne. And the nice thing about FiftyOne is that it is home base. Once you're in FiftyOne, it is the single source of truth. That means that it doesn't matter if you bring in a Coco data set, a Vogue data set, a Kitty data set, or many other different data sets. Once you're in FiftyOne, everything is on a level playing field. So if you're comparing models, evaluating models, and want to understand which one is performing better than the other one, FiftyOne is the best place to do that because everything is all in one location. Some other things to cover is that we help with all the data set conversion. I mentioned the Coco, the Vogue, everything like that. Whether it is a format conversion, merging, adding, or cloning data sets, import and export will always be helpful and handled by FiftyOne at your leisure. So if you want to bring in any of these data sets or more, or if you have your own custom data set, both can be handled in FiftyOne quite easily with only a couple for loops or by a single line if it is a known data set format. You can bring it in, or even as some of what we'll be doing today, you can use our model zoo or dataset zoo to bring in some of the best open source available models and datasets to work with to help flesh out your computer vision workflows. We can work with anything from images, point clouds, geolocations, videos, DICOM, or group datasets, which is a combination of all of the above, to help find out what exactly is happening inside your dataset. So basically, any visual AI task can be covered through the FiftyOne toolset. But more importantly, we handle all of the tasks and labels as well, whether it's detection, segmentation mask, key points, classification, action recognition, relationships, or more. All can be handled within FiftyOne to make sure that any visual AI task that you're going to be performing, training models on or more, can be handled inside of our tool. So with that aside, I am going to jump into some nice, fun, hands-on sections of our code. We'll be jumping into two main portions here. First and foremost, we're going to be jumping through this Databricks notebook that we'll be walking through in a second here. But we also have some fun examples, such as our BDD example, where we're going to be looking about how we can leverage Databricks. We also have a nuScenes example, where we're going to be using Databricks, as well as a sneak peek to one of our further partnership spotlights that will be happening later on, which is 12 labs, and we're using vector search as well here to leverage multiple different embedding sets. So a couple of things that you might need to be familiar with before we get there. First and foremost, we're going to be talking about our Databricks Mosaic AI integration. Here we have this located on our docs. I'll be sure to copy and paste this into our chat to make sure that everyone has access to this as well. Thank you, Jimmy, for beating me up to it as well. But our Databricks Mosaic AI integration is completely documented on our website. We're going to be walking through some couple examples, but if you want to do it yourself, be sure to check it out, as this is probably your best place of following along, where you can link out to any of the questions you might be having. I also highly recommend checking out the actual Mosaic AI Vector Search documentation if you're interested, where you can learn more about how Databricks is leveraging Mosaic AI's Vector Search to get the best performance out of your data sets. This is all documented as well if you want to find a notebook that can help you teach you how to do this yourself. One of my colleagues, Paula, has this awesome FiftyOne GitHub repo, which talks all about how you can use FiftyOne, including the Databricks Mosaic AI integration. I will be following a form of this today, so be sure to follow along if you want to understand more how to use this, as well as we have a great blog that just came out as well, which talks about how to do everything that I'm showing you here today, also with 12 labs and Databricks. We were fortunate enough to actually publicly and officially announce our Databricks integration today. So if you want to check that out on LinkedIn as well, be sure to do so. Without further ado, we are going to jump into the meat and potatoes of today's webinar and look at some hands-on code. While I present here, if anyone has a question, be sure to drop it inside of the chat or the Q&A widget, which I don't know if we have today. Yeah, we do. If you hit the More button or just on the Q&A widget, if you drop your questions into there, it'll be very easy for me to answer them as we go along here. So if at any point anyone has a question, maybe I need to just repeat something for clarity's sake, be sure to drop this into the Q&A. We have plenty of time here, 45 minutes left until the top of the next hour. So I want to make sure that everyone comes away with the most help possible. So I'm going to dive into this notebook. Feel free to ask away. I'll be here to help. But without further ado, let's just jump right into it. So what am I doing before we get started? What am I actually looking at here? Here I have a Databricks notebook. I'm running inside my Databricks integration, right? So my organization has set up Databricks. I have some data that I've uploaded to Databricks already. Now, if you don't want to use inside of Databricks, you can follow this all along in some open source versions and things as well. Paula's GitHub repo will cover all of this. But I'm going to make the assumption that you are a Databricks customer and you do have data in Databricks. Now, like I said, minor changes here and there if this is one case or the other, but I just feel like it'd be the most helpful to put your shoes into what a real world use case would look like here. So once you have your data in Databricks, and I am running in a workspace here, only one other thing that I've done here is I have a catalog here called Quick Start. And in my Quick Start catalog, I have a bunch of data. I'm going to call this samples as well as Quick Start. And basically, I have a folder full of JPEGs. This is my raw media. And then I have a table here that has all the metadata that is associated with my raw media, including my object predictions, my ground truth, everything that you would expect to have in a computer vision workflow. How does this all work for me? Well, it's very easy. You can always just export your FiftyOne data set and then plug it into Databricks. If you haven't done this before, you just have to export as FiftyOne dataset format. That's going to output some JSONs for you. Those JSONs are fortunately automatically ingested into Databricks, so you don't have to do any type of configurations. As long as it correctly populates the table for you, you'll be able to automatically ingest that data in, as well as you just have to drop the raw media, such as your JPEGs, things like that, into a volume on Databricks, or at least connect it to wherever that is located on your cloud that is connected to Databricks. Once again, if this is all running locally on your computer, just load into a FiftyOne dataset and everything will work the same as well. We're just doing this as if we are a Databricks customer. So moving forward, a couple of things that we need to install first, mainly just Databricks Vector Search and FiftyOne. The rest, the FiftyOne Torch Vision UMAP, is all going to help mostly on the ML ops side of things. So we install this, but since we're in a Databricks notebook, make sure that we just restart our Python environment afterwards as well. Next, it's important that we set up our environment variables. This is pretty easily, as you can just set it up through your catalogs. Make sure you set up your vector search endpoint and create a schema. So if you haven't done this before, catalogs are the driving kind of data collection in Databricks. Each one can have vector search endpoints as well. You don't have to create the index yet. You just have to set up the endpoint so we have compute to bounce off of. As well as make sure you have your schema, that's our tables and everything that we'll be working with as well. Make sure you load in those environment variables as mentioned through an environment file. Basically, we just need to know where your URL is, your personal access token, as well as the actual catalog and endpoint you're going to be working with. Once you've loaded this in, we have a couple other ones that we can optionally start with, but not needed. It just depends on how you're working with it. So if you're doing this outside of Databricks, or if you're doing this directly in FiftyOne, just follow these different steps if you need to. These are all marked as well in Paula's GitHub repo. Afterwards, the next thing you need to do inside of your Databricks notebook is we need to make sure that we are actually targeting the correct database that we're going to work with today. In this case, my database is called Quick Start. And in Quick Start, I am having my data set that I'm going to work with, everything like that. So make sure you just use the Spark command to target that Quick Start data set. From there, we're going to start adding up our new configs that we're going to be using for our vector search. Namely, we have to name the index that we're going to build, which we are going to call our first index in Mosaic, as well as the similarity chords. These are going to come in handy later, so I'm not just constantly defining things, but these can be any names that you want, the index name, the catalog name. These just have to match correctly with the ones that you're using on your backend, right? So these you must provide this portions are mandatory to make sure that you have access to all the proper data locations. So I know this is a lot of config, but finally we're getting there to where you start your client. This is going to authenticate you inside of the Databricks notebook. You can see here I am authenticated as myself, Daniel. And then from here, we can actually start opening up our catalog. So we're going to start our catalog. All this code that is commented out, this is only code you need to run one time. So if you haven't created your endpoint yet, make sure you create your endpoint, set up a schema, and then set up direct access to that endpoint to make sure you're able to access it. However, if you've already done this, you can do list endpoints, and we'll be able to see that our endpoints already exist. Okay, so let's take a deep breath. Now that we've done all of our config, basically what we have is data inside of Databricks, right? That's in my catalog and my volume. I have an endpoint set up for vector search that now if I was to upload embeddings to, would bounce those embeddings back to me in a way that is performant through Databricks. And 3, I have been completely authenticated through Databricks. So whenever I run Databricks commands inside this notebook, everything will work as expected. I'll be able to connect to my catalog, everything like that. This is going to be tested in our next notebook step here, which is actually loading our data into this environment. So when I go to load my Spark table here for quick starts samples copy, then if everything is configured correctly, I will load back this table, and we can see this by displaying this data frame. And sure enough, I can see that my data is loaded in. I have my file paths, but not just that, I have all the other metadata as well. Now, the first thing that is important to notice is that I loaded my data in. This file path is not properly configured, right? We notice this data and then the file name. However, now that I'm in Databricks, this data front-end directory is no longer accurate, and it needs to be changed based on your user and setup and everything like that. So how do I do this? I'm going to quickly replace everything in my table from data to the actual location to where that data lives. Now when I go back to this table, I see it no longer says data JPEG, but it says volumes, quick start, volume, JPEG, right? And for anyone that doesn't know Databricks folder structure and things like that, volumes is where I store all of my volumes. Quick start is the name of the catalog. Quick start is the name of the schema holding it. The quick start volume holds the raw media, and then the JPEG is the actual one. I know that's actually a mouthful, but basically, this is how you have to drill into all the different names of your Databricks in order to get to a file path that we can actually access and visualize. Why is this the case? Because FiftyOne is not actually a database that holds the data for you. It's a logical database, which means you just have to point me to where that file path exists in your environment, and then I will be able to visualize, work with it with you. Okay, so now that we have that set up, we need to now transform our structured Databricks dataset into our now unstructured FiftyOne dataset, right? So one of the tricky things with working with visual AI is that it is by nature unstructured data. You might have many different bounding boxes. You might have a lot of different information stored in your dataset. It doesn't always fit nicely inside of a table if it's not serialized. And so in order to visualize and work with it all the ways we expect, we have to unstructure it from that table. How do we do this? It's pretty simple. We just need to make sure that when we pull that dictionary off the table, we can format it into a FiftyOne detection. In order to do so, we have this build detections helper function. And so sure enough, what we're going to do is we're going to start a new FiftyOne dataset. Once again, if you're not super familiar with FiftyOne, be sure to check out some of the links that Jimmy has dropped inside of our chat of all different ways how to learn FiftyOne. But basically what we're going to be starting to do here is we're going to create a new empty data set called Databricks Quick Start. And then for every row in my data frame here that can hold all my different data set knowledge, we are going to go row by row, grabbing the file path. This creates a new image sample for us. Then I am going to build the ground truths on top of my image. I'm going to build my model predictions, as well as I'm going to add the uniqueness, which is a metadata sample. After I have these 3 metadatas added on top of my original new sample, I can then add that sample to my data set. We are going to let this run, and then once it runs, we can launch the app and we can begin to visualize our data set. So let's not jump ahead to embeddings just yet, but we can see here I have my model predictions in light green, and I have my ground truths in dark green. So I can begin to understand my computer vision data set, click around, visualize all my different predictions as well as ground truth, as well as I could go into the sidebar here and begin to do other custom things such as filtering by label. Maybe I want to look at only my airplanes right now, or I can add in another class as well, such as backpacks, where I'll find samples with backpacks as well as all the other additional kites and everything like that that are available inside of Quick Start. So now we have loaded our data set from our Databricks volume into FiftyOne. We now are working with visual AI in visual manners, where we can now slice, curate, filter, and all those other awesome things that I mentioned at the beginning of this webinar inside of FiftyOne, but using the power of Spark and Databricks as the backend. So moving forward, how do we bring Mosaic into this? Because we want to take it to the next level. So next up, we want to compute our embeddings and index with Mosaic AI. What we're going to do here is we're going to use a clip model to generate the embeddings. We are then going to push them to our Databricks endpoint, and then we are going to store them as direct access. That way we can directly kind of manipulate them when we go into our app again. So this time we are going to just make sure we restart from fresh. Make sure you get this client. This can be a tricky part. I want to note anyone that is going to follow along with this at home or is going to watch this video back in the future. Sometimes when you start your vector search client and you connect to the endpoint, the index needs to spin up and become ready. This readiness doesn't always happen right away, and it's totally normal if you have to run this block of code twice, okay? One is essentially waking up the endpoint, and then the second time will execute on the endpoint. This is noted here, as you have the index might be ready. So if you get an error and the error is related to this, do not freak out. This is okay. It's just a matter of it spinning back up. Just run it again and it should be okay. You might have to run this one first and then this one second, so on and so forth, but it's totally normal to expect this. It's just a matter of booting processes up in cold start. So once you've done this, what this actually is going to do is this is going to create our Mosaic index. It's going to create that table for us. We don't have to actually go into our schema, catalog, or tables at all and build the vector search. Our integration will handle all of that for you. And this is where we pass in our quargs and some of the stuff from earlier to help manage that as well. So once we do this, we can run our similarity. We're going to have these embedding vectors stored now alongside all of our different samples. We can print this to confirm it. And now we can do other exciting things, such as visualization. So here I am going to visualize my embeddings. I'm going to use that same backend once again. And now when I go back to my app in FiftyOne, let me find that again. I can actually visualize my embeddings side by side. So when I go side by side here, I can see my visualize, and now I can begin to interact with this. Samples, cut into this however I like, and work with my data set. So in only a couple steps here, I've now jumped all the way through my Mosaic integration. I am now working with it in my Databricks notebook with Databricks dataset. So I can understand exactly what I'm working with. I can query on this. And so now I'm going to show you kind of how we can apply this to all the awesome fields and industries, including AV datasets in FiftyOne. So I'm going to jump to a new tab here. We are going to be looking at our BDD dataset in this case. And our BDD dataset has our embeddings already preloaded on them. I have a bunch of different ones loaded on them, and I can go side by side here with my embeddings and my dataset. So keep in mind, this dataset has 10,000 samples. This one's a little bit more sophisticated than the last one. The last one was for demo purposes. This one is a real computer vision dataset where you can see I have multiple model predictions stored on it, polylines for the lane detection, detections, time of day classifications, scene, weather, and such. So an example workflow could be potentially show me all my rainy, let's say, nighttime samples that are happening only inside of the city. And so just like that, I can kind of fine tune into exactly what I'm looking for, and I can find all 196 samples from 10,000 that I was working with previously. However, it's very typical inside of autonomous vehicle datasets that you don't know what you're looking for, right? I mentioned this petabyte of data problem. How do you deal with this? Well, let's first jump in by looking at our embeddings and understanding how we can leverage them. The first thing that I want to point out here is that you can color your embeddings by any number of metadata that you've stored on top of your data set. In this case, I can color them by time of day. Now these embeddings are visualized here. The backend is running on this Databricks, and I can begin to query into them. So I'm going to grab the top of this cluster here. I can do a little bit of cluster analysis. I can see that most of these samples are long highway driving. If I grab the opposite side of this cluster, what's the opposite of long highway driving? Well, we will see clustered city driving. I can also do this to help find outliers in my data set. So if I grab this little cluster here, what am I going to find? I'm going to see that it's all tunnels. This is an outlier I want to include in my data set. But FiftyOne also allows you to help find mistakes and outliers inside your data set as well, where I can see all these nighttime samples that are on the wrong side of my data set here. And I can find outliers such as some mislabels. This is clearly just a mistake. Daytime labels night. I want to fix that before my next training run. But some of them are just true outliers, such as Times Square, New York. So this helps you understand and find gaps in your data set, understand the distribution, and work with it. I saw that we had a question in the chat. Vishnu asked, are you clustering them based on VIT embeddings or just captioned tags? Great question. We are clustering these based off the clip embeddings. It's a visual text transformer, which allows you to kind of visualize this and work with it in both semantic and visual properties. You can bring, however, any embedding model that you want to bring, whether it is a publicly and popular open source one that we can help provide to you, or you can bring your own model in and upload those embeddings. It is completely flexible for whatever we want to work with. If we go back to our notebook, I can point out this step here that once we get to our generation here, I am passing in this model. It's called clip VIT base 32. But you will note that when I do my second one for the visualization, I am just passing in the embeddings from that previous output. Similarly, this embeddings can be any embeddings that you want to pass along. So it can be embeddings on the visual, it can be embeddings on the captions if you want to, if you have captions on it, but it can be completely flexible for whatever embeddings you want to do. From there, I am doing a UMAP dimension reduction, but this could just as easily be PCA or TSNE as well. I hope that clears up your question for you. Awesome. But one of the exciting things about Clip that I wanted to bring up as well, which we're jumping ahead to almost, which is great, is that I can also type in anything that I want to inside my search bar here. And this rainy intersection, for instance, is going to search across all of my data set to help find all the rainy intersections in my data set. This is now backed up by the vector search again, but this time it is using the similarity portion, not the visualization portion, to help sort my data set based off the prompt rainy intersections. Now, when I look into my data set here, sure enough, I find the Holland Tunnel, not too far from my house, and other rainy intersection locations. We can get some really interesting samples such as this one, where you can see the rain is quite significant, but we're clearly still at a traffic light as well. So you can help find these edge cases, even though you might not know exactly where they are. It's important to note, too, that this workflow that I've been doing so far can be, for the most part, largely unlabeled as well. You do not have to have labels on your data set in order to search semantically, in order to visualize clusters, in order to do cluster analysis. Everything can come unlabeled, and everything I've shown so far will still work all the same. So this is all great. Now, how do we begin to work with this in intelligent ways for autonomous vehicles? And we'll look at a couple other examples as well. But the way that we want to work with this is so much autonomous vehicle data sets are useless. And this is not something to get offended by. It's something to be proud of because we are very, very good at certain problems in autonomous vehicles now. For instance, if I grab this type of cluster right here, right, where this is our long nighttime highway driving, I would fully expect my model to be highly performant in this scenario. It's just for the matter of a sample that looks like this, and let me turn off everything. If a car driving in a scenario like this is pretty easy, right? Like I know where the cars are. It's very unlikely that I have certain events happen. And for everything, it's not too many things to detect. It's just a small number of cars and such, right? As we can kind of see here. Unlike though, however, if I grab maybe my bottom side of the cluster here, even though there's a similar amount of samples in my highway samples versus my city samples, I can see here that maybe a scenario such as, let's find a good one here. Um, let's look at a scenario like this, for instance, where now I have um, pedestrians crossing the street. I have many lights going on. There's much more cars. There's might be more intersections. Traffic patterns might be more unusual than how you would find on a highway or a common road. So now there's a much more high level of alert that I want my car to be even more performant on, right? Especially if you're not geofencing your data set or your model here. If it's just raw, drive this autonomously, we want to be really good at these like pedestrian locations at nighttime in a city, right? We can see the number of detections can highly jump up, where you can see I'm supposed to be detecting every single one of these pedestrians to make sure none of them are going to jump in front of the road. So how do we find these samples? Well, it starts by doing just what I did right there, right? Where I can actually click in and begin to search using my lasso search, my vector visualization to find the most important samples. I don't want to be training my data set on me pulling out of the garage over and over again, right? Nor should I have to go get this data annotated or spend money on it getting annotated, right? We only want to spend money and resources on the most important data points. This could be things like unprotected left turns. It could be things like um, nighttime with a lot of pedestrians, like we just saw. It could be weird traffic patterns, right? It could be when someone cuts you off. All these kind of things that we're looking for in our data set, which is the most important, right? And we can help find a lot of that with the vectors and embeddings. So once again, we can grab things like outliers, such to figure out where we're working in our data set. We can also use this to help find where we're missing data, right? We can see that, for instance, we grabbed this tunnel view earlier. Am I really okay if I only have 23 samples in the tunnel? Now I didn't know that I had such a gap in my data set. I might want to go back and actually collect more data inside of tunnels or generate more data synthetically inside of tunnels. That way my model will be a little bit more confident. Who knows what might happen. One of the big problems in autonomous vehicles is that actual moment you go into a tunnel when the light changes very significantly. We want to make sure that we are prepared for that. I see that we have a question in the chat. Let me take a break real quick to answer this. Someone mentions that we are currently working with YOLO V8 models for real-time object detection and edge devices. Can Mosaic AI integrate with or evaluate third-party detections from YOLO-based models? Great question. Thank you for asking. While Mosaic AI is not going to be able to evaluate that from third-party models on potentially other data sources, FiftyOne can, right? So it doesn't matter what format you're bringing your data set in. It is completely agnostic as long as it's inside of FiftyOne. Then you can begin to evaluate any number of data sets and things like that. So we do have a Ultralytics or YOLO integration. So if that is something you're using under the hood, it will be very easy for you to work with it. So I encourage you to check it out, and I'm sure Jimmy can drop the link to that as well. In demo notebooks, this data was sequentially loaded from a Spark data frame Spark table, including generating embeddings. Where comes a Mosaic AI in the picture? Great question. So the Mosaic AI integration is currently what is driving our vector backend, right? The performance, leveraging the similarity as well as the speed is coming from the Mosaic AI vector database, vector search backend, right? So when I go into here and I click into a cluster, that is querying my vector search on the backend here, okay? Feel free to integrate Mosaic AI in many other ways, such as our users do as well. MLflow is a great way to get involved. They have a bunch of models and endpoints and some intelligently things. However, most of that in Databricks today is on the text querying caption table side of things. It's not very native with visual data, and we're trying to bridge the gap through the partnership that we have with Databricks. So while I can't speak publicly yet on all the exciting things that we're building with Databricks right now, you're going to have to keep your eye out for some of that in the coming months. This is only our first step with the Mosaic AI integration. And I actually am able to give you at least one sneak peek, maybe two, if we have enough time into what we are building afterwards. But it's it's a little hush hush as we can't speak too much publicly yet. So for right now, great question. Right now, only the vector backend, the vector search, and leveraging the vector speed without having to move anything off of your Databricks platform, without having to do too much configuration. FiftyOne and Mosaic has built that integration together to make it a tight-knit relationship, right? So you can work with your data in Databricks visually and at scale. So jumping into our next portion here, how do we actually scale this out into the petabyte scale, right? This is one of the things that, I'll just jump ahead to one of the things that we're working on right now, something that is publicly available for our enterprise customers today. And if you're interested, really impacts those who are working in that petabyte scale is what we call the data lens. So in Data Lens, you can work with basically your Databricks backend. We're still using with our Mosaic Vector Search here, except this time I'm now trying to find new samples. So assuming we have generated embeddings on at least a significant portion of that petabyte of data that is being stored inside of Databricks, how do I actually pull it in visually automatically without having to jump into that notebook and load in the data frame as we've been mentioning in the chat here? How do we skip that step, right? How do I just work instantly with my visual data, apply models, evaluate my data set without having to do that notebook flow every single time? And the answer is with Data Lens. So while this is available in our FiftyOne enterprise, it's for our users and customers who are working on that insanely big scale where you probably have this up in the cloud anyway, and enterprise makes a lot of sense for you. So in this case, what we are going to do is there's two ways to search. One is through contextual search, and one is through our metadata. So the same way that we've been clicking over here on the left side, we can do here on the right side. So this one is going to generate one type of query, but the one that is going to use our vector search here is our contextual search. So I can type something into here such as, let's say, stop signs. And I don't want to do this. What this is going to do is this is now going to query my vector endpoint, the same one that we created previously. It is now going to query over all the embeddings inside of my data lake that might contain samples much greater than 10,000. It could be a million, a billion samples potentially. And it's going to create a preview of 25 samples here of stop signs inside the data lake. So what this is doing is going to create a new embedding. It's going to ping it, and it's going to come back to me. And I'm going to get some results back. So we can see that the clip model represents some healthy ones. However, some of them are getting confused here with stop signs and traffic lights. So this helps us understand if it is a healthy enough query for us, if our embeddings are performing well, or what we're looking for. So we can see here all the different preview results. Maybe you're not totally satisfied with it, but you can always click in and import the ones that you are satisfied with, or you can go back and run this query again. So depending on what you want to work with here and on your embeddings, now I don't actually have to go into the notebook. Now I can go into here, click import when I'm ready to import this new data set, or work on this query back and forth where we are still doing the vector search. We're still looking for those samples that are interesting for us, but we don't have to jump into the notebook every time. We're doing this only in the app where we can work with this in a continuous way. So if you're looking for new scenarios, if you're looking for new environments, everything like that, this is the best place. And also, this is also the best place for you to actually integrate with all the potential powers of Mosaic AI, because this panel that you're seeing here is completely customizable in Python. So if you want to add in things like, let's say, agents through Mosaic AI that are talking to your data set through captions or through elements that are available inside of your schemas or things like that, this query can be as simple as stop signs or as complex as an agent conversation back and forth that then queries and pulls your data back in. And this is something that we're actually seeing our AV customers do today, where it's not simple enough, as you can actually see in some of these conversations here, to say just stop signs. I want to go back and forth, say stop signs, get some information back, say like, no, I'm not saying stop signs like red traffic lights. I'm saying stop signs like the red ones that are actually stop on the words. You can go back and forth until that data is properly queried back for you, and then be able to deliver and import that data set into FiftyOne, where then you can continue your workflows such as building these awesome new training sets, evaluating the model performance onto these new samples, or much, much more depending on your use cases. But it is very flexible with how you're building with this. So this data lens is something that is publicly available today to our enterprise customers. And as I mentioned, there's some exciting things that are being built under the hood to make Data Lens even more incredible that I can't publicly speak about yet as well. The next thing is that you can do this across any type of data sets, right? So here in our nuScenes data set, we can see I now have point cloud data. I have visualizations on all my cameras that are coming in here. I can also go into, I believe in this data set. Oh, it's in my other one, but I can also load my embeddings in here. I can also do the data lens here as well, right? So I can go side by side. I can go to Databricks. I just have a new one for nuScenes. And you can even begin to pull in things like not the entire scenario, but just the first frame, the full scenario, the keyframes, and work with it in a much more autonomous vehicle context than you would in, in the previous example, right? So it doesn't matter if it's point clouds. It doesn't matter if it's 3D bounding boxes or anything like that. The workflow is completely flexible and customizable. In fact, if we jump ahead to our next one, you can work across this in any type of modality. So we can do things like videos as well, where in this case, we have a video data set of many different general types of videos. And we can query, in this case, with 12 Labs. One of our partners with both Databricks is partnered with 12 Labs as well as we partner with 12 Labs. I can begin to pull up video embeddings, right? I can begin to grab this and understand exactly what is happening on my left side of the video. So this works across any industry. It doesn't have to be autonomous vehicles. It can be general videos. It can be manufacturing, anything like that. In this case, we can see we grab all these musical instruments and musical activities, but we can also switch this to audio. Works just the same. If I grab the bottom right cluster here this time, it's not going to be musical instruments, but it's going to be a lot of whirring sounds, for instance, because it's the sound happening inside of it. So grinding meat, mowing the lawn, recording music, riding a bike, shredding paper, welding, all sounds that sound like, whirring sounds, I guess. So it's very flexible. I see we have a quick question. I'm going to keep going, but let me answer this question. For videos, do you have any frame difference methods to pull up important frames plus usual image pipelines, or is this a new model entirely for videos? Vishu, great question. So there's multiple ways you can encounter this. You can store things on the frame level on your data set. So if I click in here, you'll notice I didn't store anything on my frames here because I'm actually working with the entire whole video in the context of this example. However, in a different example, you could work with it in the context of a frame, designate keyframes, have methods to pull up important frames. Like I said, FiftyOne is very flexible in this way. It's built for builders. So if you have your own methods, as well as we have methods we can show you through popular open source models and methods as well, to do whatever works best for your use case, right? So there's no limit on how you can work with videos or images or any of our data sets. It's much more of just which workflow is the best for your use case. I hope that answers your question. Keep the question coming, guys. This is great. I know we're winding down here, but I want to make sure I answer everyone's question that they might have. That way, everything is simple. And then lastly, that I wanted to go over today, we can also sort by similarity as well. We've been doing textual ones, but you can actually click on a sample and say, find me more samples like this. So in this case, we're going to find archery. I want to find the 25 most similar samples to archery in my data set here. This is once again going to query my Mosaic backend, pull up it to me, and we're going to find archery, but then we actually find axe throwing. Then we're going to find some hammer throw, someone playing basketball, some more hammer throw. And then as we go further down, we're a little bit further away from our context. We can also, once again, do this with audio and things like that as well. So it's super flexible with how you work with it. You just got to tell FiftyOne what you're trying to look for, and we can help deliver some of the best state-of-the-art tools, such as image similarity, text similarity, vector visualizations, and much, much more. Let me highlight, too, that this is only one aspect of FiftyOne that we've been exploring today, which is this searching and curating with embeddings. There's much, much more to dive into, and I can't cover it all in 1 hour. Such as evaluating, model development, finding mistakes, annotations, cluster analysis, and much, much, much more. But stay tuned to all the other Voxel51 events if you're interested in learning more about those, as they'll all be available and be other tutorials and explanations on how to do that as well. We did get another question in, so I'm going to answer it. I'm going to open up the questions as we have about 10 minutes left. I want to make sure that everyone has questions and gets the resources they need. So the next question is, for real-time videos, can they be processed? For example, segmentation or object detection from a Raspberry Pi 5 and camera. It's a great question. Let me note the key difference here, that segmentations, object detections, and videos are totally plausible and okay with us. There's nothing stopping us from doing those, right? But in terms of real time, FiftyOne is probably not the right tool for you, right? We're not a model deployment service. It's more about a data introspection tool, right? Curation, debugger for the data set side. So if you have data that is coming off the Raspberry Pi that you want to make sure is not data drift, it's not model drift, you can definitely set up a pipeline from your Raspberry Pi into a 51 instance, run the model to make sure it's running correctly, and then verify those results. Just know that real time is a tricky situation here where it's not built to be deployed, right? Like a model endpoint or a TensorRT endpoint or whatever it might be, how you're deploying your edge devices. It's much more, afterwards as a example. Should the video be uploaded with the bounding boxes? Great question. Everything in 51 is in its own format. So you can upload the raw videos, right? And when I say upload, 51 open source runs locally on your computer. When I say upload, I really mean communicating with the Python SDK to let me know where those videos live. So nothing hits our APIs, nothing runs on our servers, everything runs for you. So should they be uploaded with the bounding boxes? When you upload with bounding boxes, tell me where the raw media is, and then tell me where the bounding boxes are on each sample, right? This is a great question for like 51 getting started workshop. If you're perfect timing, Jimmy, where everything in a bounding box in 51 is just normalized XY with height. So you just have to pass me like a dict of what all the bounding boxes are essentially, and we will load them onto the data set. That way you get a full kind of experience where you see when I hover over a bounding box in my data set here, I can get all the metadata that I've stored on my bounding box. I can get the visualization of it. It's not painted onto the image, right? It's a Python relationship here of I've stored on my detections here all the different bounding boxes on top of it. Great. I hope that answered your question. I know it's a little bit involved if you're new to it, but it's very easy once you get the hang of it. Any other questions from the chat here? Thank you again, everyone, for hopping on. Like I said, a lot of really exciting things building from Databricks. I don't know if anyone else was at the Databricks Summit this past week. I was. It was an awesome experience, and I had a nice couple sit-down meetings about the exciting future of 51 and Databricks. So keep your eye out on the horizon for even more exciting announcements regarding our relationship and partnership with Databricks.
It does look like we have another question that came in, Dan. Is it possible to deploy 51 locally alongside with a local Databricks Docker? I would like to build an image RAG pipeline with this, if possible.
Great question. Thank you, Jimmy, for grabbing that one. I think so, yeah. I don't see why not, right? 51 is a pip package. It's just pip install 51 to get started. So if you're wanting to deploy this inside of a Docker container, that is totally feasible and doable. And I've seen many people do it before. So assuming your Databricks side, I can't speak too much on how to deploy that. Assuming your Databricks side is all set up and configured already, then yes, you could also add 51 to that workflow as well for a RAG pipeline. That's a perfect example on how to leverage what I've just demonstrated today.